The tire company claims its tires have a mean life of at least 80,000 miles. A manager at a local Kansas City tire distributor tested 40 tires manufactured by the tire company and found the mean life to be 78,500 miles with a standard deviation of 3,300 miles. What is the population? The population would be all tires manufactured by the tire company. What is the population parameter we are testing? We are going to be testing the mean life of all tires manufactured by the tire company. What is the point estimate? The point estimate came from a sample of size 40, and it's 78,500 miles. It's the sample mean. Run a test to see if the tire company's claim can be rejected. Okay, it appears we have some evidence against their claim, so yes, we can run a test to see if that evidence is strong enough to reject their claim, to show that something else is true. Now, what we're going to assume is that the tire company's claim is correct. We're going to assume that the mean life of all its tires is, as they say, at least 80,000 miles. Now, our research hypothesis, or alternative hypothesis, is that that mean is less than 80,000 miles. And we have some sample evidence to support that. But remember, it's just a sample. It's only 40 tires. It doesn't automatically prove that their claim is wrong. The real question is the sample evidence strong enough to reject their claim? Now, the first thing you do in a hypothesis test is to set up the null and alternative hypotheses. As mentioned in the literature, another way that we could do this is to not test the null hypothesis mu greater than or equal to 80,000, but to test and assume that mu is equal to 80,000. Because if we prove that mu is less than 80,000, certainly proves that it's not greater. Step 2 of a hypothesis test is to calculate the standard deviation of the sampling distribution. We are sampling, we are taking a sample of size 40, and we have to know where sample averages of size 40 would fall, and where they would fall given that the null hypothesis is true. If the null hypothesis is true and the mean is 80,000, then that's going to be the center of the sampling distribution. The standard deviation of the sampling distribution would be calculated as 3,300, which is our estimate of the population standard deviation. And since we're taking samples of size 40, we'll divide by the square root of 40. And that will give us 521.78 for the standard deviation of the sampling distribution. Now, they had a sample of size 40 and calculated the mean on that sample to be 78,500. If the null hypothesis is true, that 78,500 should be pretty close to the 80,000. One way we could be convinced that the null hypothesis is not true is if the z-score of the 78,500 was a -3 or more. Remember the empirical rule. The sampling distribution is assumed to be normal. The empirical rule says that all of the values within a normal distribution are, well, almost all, are within 3 standard deviations of the mean. So if 78,500 has a z-score of less than -3, then it is beyond 3 standard deviations of the mean. And if that's true, then this can't be the sampling distribution. The null hypothesis is incorrect. Now, our alpha value was given at 5%. That's the level of significance. In some sense, that's the risk we are willing to take in running this test. It is the probability that we'll make a type 1 error. And I use it to draw a decision line. 5% of the sample means will be in this region. So, if my 78,500 turns out to be in this region, to the left of this decision line, I'm willing to go ahead and still reject the null hypothesis. Only 5% of the sample means would be in that region if the null were true. And if my 78,500 turns out to be one of them, I'm willing to go ahead and say that the null hypothesis is incorrect. Now, there would be at most 5% probability that I'd be wrong, but that's a small probability. I'm pretty confident then that the null hypothesis would be wrong. I'm taking some risk, but I'm willing to take that risk. I've set alpha equal to 5%. Now, how do I know where the 78,500 is? Is it far enough away from the 80,000? In other words, it's to the left of my decision line? Or is it too close to the 80,000 to reject the null, so that I wouldn't be comfortable in rejecting the null hypothesis? To determine that, I calculate a z sub alpha, which is the endpoint of this interval. Now, since I'm using standard normal, I would go to the standard normal table and have to look up 0.45 to find this z-score. And this was a common z-score, so it's negative 1.645. My rejection region is any z value less than or equal to negative 1.645. It's the interval from the decision line to the left. Reject h sub 0 if z is less than negative 1.645. What z are we talking about? We're talking about the z-score of the 78,500. How far is it from 80,000 in standard deviation units? Or what's its z-score location? If I do this calculation, I get a negative 2.87. So my 78,500 is to the left of my decision line because its z-score is negative 2.87, and that is smaller than the z-score at the decision line, which is negative 1.645. This value is called the test statistic, and it is the location of my point estimate, my sample mean, and it shows that that location is in the rejection region. It's far enough away from 80,000 that I'm comfortable in rejecting the null hypothesis. So my last step here would be reject h sub 0, and my conclusion would be the tire company's claim is incorrect. The mean life is less than 80,000 miles, not at least.